Hello everyone, so this is going to be a quick introduction to functions and functional programming. So we're going to start out by just looking at this example again that we introduced last time. So this is a forcing function with respect to p, where p is discretized with respect to time. And so we're going to take this forcing function, 10 times sine of pi t over 0.6, and we're going to modify it, just make it more in terms of variables, so then when we recalculate those variables, everything is calculated automatically. And so we're going to take 10 as p naught, that's the amplitude of this sine curve, and then we're going to actually take a frequency of pi over 0.6, so that's the frequency of this sine function. So we're going to say p naught equals 10, and we're going to say our frequency of our forcing function is pi over td, and our td is going to be 0.6. That's just the amplitude or duration of this pulse. Okay. And then we're going to define some forcing function, p at t, which is going to equal p naught times sine of w times t. And right now, this shouldn't work, and it's because the name pi is not defined. And so we are going to have to load some libraries in order to be able to read some of this. And so let's import a few libraries. We'll import math as m, and we're going to need the numpy library because we're dealing with vectors and arrays, and so we're going to import numpy as np. And so we'll just run these imported libraries. The frequency now runs, and we have not yet defined the time needed as input for this p, and so let's define time with a linspace function that starts at time 0 and ends at time td, and is going to have some sort of number of steps associated with it. And we'll just say that that number of steps is associated with the final time, which is td, over whatever time increment that I wanted to step at. So let's say the time increment is 0.1. Just to ensure that this number is an integer, we'll explicitly say that that number of steps is an integer. And let's go ahead and print p. And the name sine is not function is not defined, and that's because it's taking an array, and so it needs to be a numpy sine function. And we're looking at something here that's 0, 7.07, 10. It's not quite right. So 1, 2, 3, 4, 5. First of all, it only has 5 points, whereas if I go to my curve, I need 1, 2, 3, 4, 5, 6, 7 points. So something isn't quite going right, and I think it has to do with what we're doing here for how we're calculating the number of steps. So let's just print number of steps. So the number of steps is 5, so that means it's supposed to be dividing it by 7, but for some reason it's dividing it by 5 instead. And so the first thing, so we need to basically get to 7, so we're missing 2 points. The first thing, I think, one that is rather subtle, is that the TD starts at 0, and so when I do this TD over DT, I actually need to add an extra 1 to account for the fact that it's actually an n steps plus 1. There's an extra 0 that's happening here. Okay, so that gets me a little bit closer, but my number of steps is still down by 1, and I think it's because if I were to take TD over DT, it's 5.9, which is really, really close to 6, but it's not exactly 6. So because of some computer error. So I actually don't want this to round down in any case. I want it to round up. So I'm going to use a ceiling function, which basically means like if you were at 3.1, it would round it to 4. It's always going to round up and never round down, and that way we always have the right number of steps. And it doesn't look like, yeah, so it says ceiling is not defined. And so I actually need to say ceiling, Python. I need to look this up. And it looks like ceiling is part of the math library. And so when I go in here, what I should actually be saying is m.ceiling. And now if we were to calculate what this m.ceiling looks like, that number actually now equals 6. So it looks like we're good, and we're printing p, and now we have 5, 8.66, 10, 8.665, which is what we wanted for our sinusoid curve. Okay. And so what I'm going to do is I'm just going to put this all in the same cell. And I am going to call certain things that are going to be constant no matter what. I'm going to call this p naught and dt, for example. Those are things that in my program I'm going to specify as global variables. And what if I were just to call this forcing function 1? So this is forcing function 1, and it takes a certain TD, and it uses those global variables. So it uses basically the time step, and it uses p naught, which are the global variables, and then it recalculates this forcing function p. Well, what if I were to wanted to create a forcing function 2 that took a new TD, let's say that new TD was 1.0 seconds, calculated a new omega, m pi, so let's just call this TD2. It's taking new things and calculating a new p. So it has another omega associated with it, and it has a new TD2 over here. This is just a global variable. It's going to calculate a new time step T2, a new time series, and then it'll calculate a new forcing function P2. And as soon as you start doing things like this, where I'm copying and pasting and then changing the name of variables, this is where the bugs start happening. It's very easy to miss something and forget that something is called by a certain variable name. So let's compare this p and t, and now this would be called t1 and p1. It would be taking t1, and this would be t21. And let's plot it. And so I'm just going to grab, copy and paste this plotting function. And we're going to plot pt. So basically I wanted to create two different variables. And I'm plotting p, and I don't think we really need a title. And so we'll plot t1 and p1. This could be p1. We'll make it a color blue. And then we're going to plot a second t2 and p2, and that is going to be a color blue, maybe. And let's just erase all of our inputs. So to do that, I'm going to replace basically all of these variables and restart and run all my cells. And let's plot these new functions, t2 and t2. And it says, oh, see, I've already made a mistake. It already says name td is not defined. And so this should have been td1. That's my new td1. And I guess this should also be td1, and this should also be td1. And let's restart and run all. And I'm just overwriting this omega. And name plot is not defined. Well, that's a totally different thing. I need to import my plotting library. And it's plotting them both as blue, so now let's plot them as red. And so we have a p1 of t with a time increment of 0.6 seconds and a p2 of t that has a time increment of 1.0 seconds. And I could actually modify this legend to be a dynamically changing legend. So I can say with money td equals money, and then I can just add td1 to this. So if I want to combine two strings, I just add one string to another string, and because right now td1 is a float, I actually need to convert that to a string in order to do this. And I will just use my good friend copy and paste, change this to p2, and then this is going to be td2, and it didn't like that because I had an extra quote mark there. Okay, and so now it's saying P1, that's that with that TD of 0.6, and P2 is with that TD of 1.0. And so anytime you're doing things like this, whenever I write a line of code twice, it's time to put it in a function. So functions are what I typically define near the top of my script. And functions, you define it. So I'm going to define this as a function signFun. It's going to take these inputs that are changing. So in that case, that's that variable TD. And then I'm going to put this colon, and that means that now everything that's indented under this function is going to be a part of this function. I haven't really defined what a function is yet, so let's just hold on just a sec. So what do we need it to do once we're in that signFun function? Well, it needs to calculate this frequency, and it's going to be using these inputs TD. It's also going to need to calculate the number of steps. It's going to need to calculate a new time that goes from 0 to TD in that number of steps, and it's going to have to calculate a forcing function that is equal to some global variable times the sign function times the frequency times time, and I want it to return P. And so now I've created this function that can then be called below. So right now this function is just a placeholder. It's not doing anything. It's not active. In fact, when I just ran it, Python isn't going through and checking to make sure. It's not actually putting in time or anything like that to make sure everything is working out. It won't actually go through and run through each single part of this function until I call it. It's just a placeholder. And it means that instead of doing the math twice, I can leverage this placeholder and only write the math one time. And so I can write P1 is equal to that signFun t. I'm going to call that function, and I'm going to pass it 0.6. Let's just make sure we're clear on what we're doing. And then I can create a second P2, which equals signFun, and I can pass 1.0 as my TD into this signFun function. And so instead of writing the math twice, I have two lines of code that's called the same math once. So both these lines of code, because they're doing the same math, are calling the same function to do the same thing. And so let's again just clear all outputs. And if I were to plot it, I didn't clear the outputs, did I? Let's clear all the variables so nothing from down below is sort of messing with anything up here. So we can make sure that it's not using any variables that we defined before. And it says T1 is not defined. So this is a kind of important point. So things that are in this function aren't available outside the function unless they're global variables. So for example, this function here is using P0 equals 10. It's also using this time step of 0.1. Those are global variables. They're not things that I'm modifying with my inputs or returning with my outputs. But time is only defined within that function. It's not available outside of that function. So it says name t is not defined, even though to calculate P1, it's going up here, inputting a TD of 0.6, calculating a frequency, number of steps, and time. This time isn't available outside that function. It only exists within this function. And so maybe instead of just returning P, what I might also want it to return is time. And I'm going to return two items as a tuple. And so instead of just P1, I'm going to have it return T1 and P1. And then I'm going to have it return T2 and P2. And now if I print T1, and I need to rerun my function since I modified it, it's now returning that time step along with the forcing function, and it's calling it T1, P1, and T2, P2. And then it says TD1 is not defined, so let's just modify this a little bit more. We'll define that TD1 outside of our function, and we'll define TD2, which equals 1.0, outside of our function. And now it's running perfectly, and it's not reading any of these things, any of this sort of, I'm just going to call this garbage because anytime you write a line of code twice, it's rife for error. So I'm actually just going to get rid of all this stuff down here. Okay, so what exactly is this function doing? Let's do a quick recap. Let's clear all the output. So the first thing that we did is we imported any libraries that we needed, and we then defined some sort of function that took in inputs of this time increment. It did some math with it, and then it returns two outputs in this sort of tuple. Then it can also read any global variables that are outside of the function. And so in this case, our global variables are p0 and dt. However, anything that's not a global variable, for instance, these inputs, or for example, this time that's being created inside this function, are not available outside of the function. We then said we have two TDs, duration of our pulse. One is 0.6 seconds, and the other one is 1.0 seconds. And so because both of these things are doing the same math, I'm just going to pass the duration of this pulse into this sine function. It's going to return two outputs. And then I'm just going to be able to plot it. And so just to make sure all of this clear, rather than returning t and p, let's return x and y. So I'm going to call this variable p. That's going to be y. T is going to be x. And that's going to be x. And then instead of calling this input variable td, I'm just going to call it capital T. It's the duration of the pulse. Now this capital T, this x and this y only exist within that sine function. But you'll notice I can pass it really any variable. So what I'm doing is I'm going to pass it td1 is equals to 0.6. It's going to get past this 0.6 into the sine function. So now capital T, which is what exists in my function, is going to be 0.6. It's going to do some math with that 0.6, and it's going to calculate some sort of x, which is the interval of the sine pulse, and some sort of y, which is sort of the magnitude at each interval of the sine pulse, and it's going to return that x and y, and when it does return that, that's these new variables that I'm calling t and p. And so really anything that exists in this function other than the global variables can be defined by any name, but and I can call them any name down here, but they're still going to be doing the same math with those names when they come up here. So let's run all this. It says it didn't like it. TD is not defined, and that's because that needs to go to a capital T, and everything still runs. So these x and y variables, the capital T variables, they only exist within the sine fun function. And when they're returned, I can call them anything I want. And as inputs, I can call that anything that I want, but it'll always do the same math regardless.